Welcome back. In this video tutorial, we'll look at the masking function. We'll start with the masking function. Since last time we looked at the initialization function. So go ahead and open up the masking.m file. So this this function has 4 inputs: threshold, which we defined earlier, and the 3 files that we load into memory from the previous function. So in this function, we start with find the length of the magnitude file to find the number of elements in each in the file, which should be the same for the real and imaginary also. So the first two for loops basically finds all the zeros, the zeros in those in the real and imaginary file, and replace them with ones. The reason for that is because later on we have to use like the arctension function, and if there's like a zero in the zero in the denominator, it produces an error. So replacing a zero with one is not going to produce that much of a big error and a calculation error. So it's just to help us basically bypass the error warnings whenever we have a zero on the denominator. And this is not a significant change when you change from a 0 to 1, since the range is huge. It goes from 0 to like thousands in magnitude. Okay? So the threshold part is where we do the masking. We use the m file to apply the threshold to. So if the element value is above the threshold, then we can apply a 1. If not, then a 0. So basically you have a binary threshold map. And this, once you apply this map to any image, it's going to be multiplied with the image, and it's going to preserve anything that has any pixel associated with the 1. It's going to be kept. The value is going to be kept. And if it's multiplied with a 0, and then it's going to become 0. So the background error is going to be taken out that way. So this is a masking image, a binary masking image of just 1 and 0. So the tissue will be labeled as 1 because the threshold is going to most likely be above the threshold, the signal threshold, and the error is very low signal, so it's going to be all 0. So later on we'll use this as the masking image. Now once we have that, I made a copy of the magnitude file, the original file, before I apply the masking, and I return the mask magnitude file, the real, the process real and imaginary files, and the original copy of the magnitude, just in case I need it. And here I delete some handles to clear up some memory, RAM. Yeah, so these take up some memory. Okay. You can change this. Oh yeah, okay. So here I actually clear up the Mac copy, but since I don't need this anymore, it's already stored inside this variable called MI. So don't want to make a double copy in memory. So that's where the clearing comes in. Okay. I just have a single. This is called a cell variable in MATLAB. When you have, that's why you have the curly bracelets. Curly brackets. I can say bracelets. All right, never mind. Okay, that's it for this this function. And let's move on to, since we have some time, we'll move on to partition function. So let's go ahead and open up the partition function m file. So imagine the original raw, say m file, or any files, any magnitude, imaginary or real file, is a one-dimensional array, and you want to turn that into an image, right? So how would you turn a one-dimensional array into an image? You would partition by reshaping it to an image using the dimension you know that the image was taken with, because that's how the MRI was set up, to have a certain image size. That's D1, D2, D3, and cycle. Remember that we discussed the 4 dimensions, if you will. This is the spatial dimension, and this is the temporal dimension, or time. So basically, you reshape the magnitude, real, imaginary, into 4 dimensions uh, variables here. The fourth one is the original. Remember that we have the original M file, the magnitude file, where it's not masked. It's not masked. So that's when you have 4 things here. And again, clears memory to save space. That's the theme you're going to see continuously throughout this um, MATLAB script. Have error message if it's not enough inputs. Okay, so basically that's very simple for now. Okay, I guess I'll save the next four functions for next video, just to be safe in case I messed up on this video. Alright, let me know if this makes any sense.